I just happen to be next door, Bonnie, so.
Is here.
I was like, okay, I made that mistake. I'm not gonna do it this time. But yeah, like I said.
Okay, they can hear me. Okay, guys, we were a little slow getting things going today, but we are here. And if you have your handouts from last time, if you would pull those out because we didn't get to the very last page. So we're going to do the very last page of the handouts from last time. At the top of it, it says Descartes' rule. That's great.
Grab me one.
Mm-hmm.
I'll show this class, and I'll put it to get a slide over here.
Okay. All right. Okay, at the top of this page it says Descartes' rule of signs for a polynomial with real coefficients. And what this is a test so that we can figure out, well, how many of those zeros would be positive and how many zeros would be negative. Remember, all these different theorems and rules are because, remember when we did the rational roots theorem, we came up with maybe 10 to 12 different rational possibilities. And we don't want to have to check all of them. We want in some way to be able to eliminate them. And so this is one way that we can do that. This is called Descartes' rule of signs for a polynomial with real coefficients. And this is the rule. A, the number of possible positive real zeros is going to be the number of sign changes or less than this number by a positive even integer. And then the number of possible negative real zeros will be the number of sign changes of f of negative x, or less than this number by a positive even integer. And I know those words, if you haven't done this before, sound like wah, 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 wah. But let's do an example of it. Here we have f of x is equal to x to the fourth minus 6x to the third plus 8x squared plus 2x minus 1. So first we're going to check to see the number of possible positive real zeros. So you do this by looking at f of x, and you just want to know how many sign changes did you have. So here this was a positive and it changed to a negative. So that's one sign change. And then it changed from a negative to a positive. Now I have two sign changes. Here I went positive to a positive, so that didn't change. And then positive to a negative. So I actually have three sign changes. All right, that means the number of possible positive zeros would be 3, or you count down by twos, 3 or 1. 3 or 1. This would be the number of possible positive real zeros. The number of possible positive real zeros. So you just look at the function and say how many times do we have a sign change. And of course your function needs to be written in descending order. Notice that ours started with the highest power and went down. So if there's one that's missing, like if you needed a placeholder, that's counted as not having a sign change. So that wouldn't change anything. All right, now if we wanted to find the number of positive negative real zeros, we look at f of negative x. So everywhere there's an x, we're going to substitute in a negative x. And then you just simplify that. So negative x to the fourth power, you know, if you have a negative number and you raise it to an even power, it's going to be a positive answer. But a negative raised to an odd power is going to be a negative. So this would turn this into a positive 6x to the third. This negative would become positive, so that would stay 8x squared. This one would become minus 2x minus 1. And now you count the number of sign changes. So that's positive to positive, no sign change. Positive to positive, no sign change. Positive to negative, there's one sign change. And negative to negative. So I only had one sign change. Okay, so therefore, there's only one possible negative real zero. Because if I tried to count down by twos, if you're starting at 1, you're already in the negative world. So that doesn't work, okay? So when you count down by twos, it's just until you get to 0. So now we're going to make a chart. Positive, negative. Remember, you can have positive real roots, negative real roots, and then you can have those other roots called complex roots. All right, well, our function had a degree of 4. So how many possible roots does that function have? 4, right? Highest power is 4, so it has a possible 4. Okay, here when we were dealing with our positive chances, we knew we could have a 3 or a 1, right? When we did our negative ones, there was only the choice of 1. Okay, so with positive, I had the choice of 3 or 1, and with negative, I had the choice that it had to be a 1. Okay, so now let's go across. This would have 3 and 1, so would there be any room for any complex ones left over? No, because 3 plus 1 is 4. They're all accounted for. But in this bottom choice, if I had 1 positive and 1 negative, that's only 2 of them. There are still 2 left over. So that would be the situation where I could have 2 complex roots, because you're trying to get them to equal 4 when you add those up is what's happening. Okay, that's how I'm determining how many complex roots I would have. Any questions about that particular example? We'll do one more. Yes? Okay, you're talking about from right here? Okay, so when I did this, I counted how many times the signs changed. So I went from a positive to a negative here, so that I counted 1. And then I went from a negative to a positive, so now I count 2. And then positive to positive didn't change, so I don't count it. And then positive to negative, I count 3. Okay, so that's how I got the 3. And then the rule says I find the number of sign changes, or it could be less than this number by some positive even integer. So what that means is you take the number of sign changes, which was 3, and I count down by 2. So that's how I got that 1 there. Okay, so if it had have been 6, then it would have been 6, 4, 2, 0. That would have had all those choices. Okay, sure. All right, let's look at another one. All right, so let's suppose that your function is negative 2x to the 4th plus 3x to the 3rd minus 5x squared plus 4x minus 1. And I want to use Descartes' rule of signs to figure out how many possible positive and how many possible negative real roots I could have. So first, you look at f of x. I have 1 change, 2, 3, 4. I actually had 4 changes, 4 sign changes. So therefore, I could have 4, 2, or 0. So you take the number you have and then you count down by 2s. So you could have 4, 2, or 0 positive real roots. And then when you want to determine how many negative ones you could have, you have to look at f of negative x. So you go and you plug in, everywhere you see an x, you plug in a negative x. Bless you. Bless you. And then you just simplify. And when you plug in a negative x and you look, there's no sign changes, which means there would be 0 negative real roots. Okay, yes?
So, in the beginning it has a -2 to -x. How does that stay negative and why isn't it?
Okay, this part right here becomes positive because negative raised to the 4th power is going to be a positive number.
Oh, right.
So this negative just comes down.
Okay.
Okay. Any other questions about that? So let's make our chart. Okay, we'll have positive, negative, and complex. And again, our total across the row should total up to what number? 4. That's right. I want to get a total of 4. So my choices for positive were 4, 2, and 0. So 4, 2, and 0. And in every circumstance, I had only 0 negative ones. So on this first row, how many complex would I have? How many could I have here on the second row? 2. And on the third row, I'd need 4. Okay. Any questions about that? That finishes up your homework from your previous section. If you didn't get all the way through it, Descartes was at the very, very end. Okay, so that finishes up 3.3. So now we're going to start section 3.4. Okay, this is where we're going to be graphing polynomials. Polynomials are smooth curves. Okay, they're smooth. And so what we're going to do is find out how many times it crosses the x-axis. So we're going to be looking for x-intercepts. We're going to be looking for y-intercepts. And we're going to want to know what it does on its extreme ends. Like, do both ends go up or down? Does one go down and up, the other go down and up? That's called end behavior. So we're going to need to look at all of those characteristics. And so at first, I'm just going to have in your notes something that's called graphing polynomials, okay? And we're going to put all of our information there. You may not understand everything, but go ahead and write it there because by the time you're doing your homework, when you refer to it, it'll all be in one place, okay? So this is graphing polynomials. So if you wanted to write a polynomial very generically, this is how they would do it. They would have a sub n times x to the n power. The sub, the little n down there, doesn't have a value. It's just telling you I am not the same one as a sub n minus 1. It's telling you I'm just not the same a. Okay? That's all it's doing. But the things that are going to be important for us is we're going to want to know the value of that very first coefficient a sub n. I need to know what value that is. And basically what I want to know is it's positive, or is it negative? So that's the question I'm going to ask myself. And I'm going to want to know about the value of n, the highest power on that x. I'm going to want to know, is that value an even value or an odd value? And we've made this statement before. We'll make it again. F of x has at most n real zeros and at most n minus 1 turning points. These two pieces of information in section 1 are going to tell us about end behavior. End behavior is exactly what it is. What is that polynomial doing on its two extreme ends? Is it going up, down, down, down? What is it doing? Okay. And so we're going to have a couple of opportunities here. If n is odd and a is positive, what's going to happen is this is not going to tell us what's happening in the middle of our polynomial, but it's going to tell us what's happening at the ends of our polynomial. So not what's happening in the middle, but at the ends, if n is odd, what you remember, if n is odd, one's going to go one way and one's going to go the other. Okay, so they're not going to do the same. And if a is positive, then to the extreme right, it's going to go up. Okay, so we're going to write down all those four choices that we've got. We've got if n is odd, we can go up or down. So same thing again. If n is odd, we'll go up or down. But this time, if a was negative, then I'm going to go down on the right, but up on the left. Okay, so the a is telling you what it's ultimately doing when it's very, very large. So notice when n is odd, the two ends do opposite. Okay, and the right hand end does whatever a is. If a is positive, it goes up. If a is negative, it goes down. If n is even, then those two ends are going to do the same thing. It's either going to be up, up, or down, down. And if a is positive, the two ends would both be up. And if a is negative, then the two ends would both be down. So it's not telling us about anything in the middle, it's just telling us about the end behavior. So that's step one. So in step one, we're going to look at our a's, our n's, and find our end behavior in order to be able to graph this. Then step two is we want to find our x-intercepts. When we find our x-intercepts, you remember what we were doing before? It's when we factored that polynomial, we could look at each factor and then pull right out of that every x-intercept, right? The other thing that we talked about was looking at that factor and deciding, oh, look, that has a power of 2, which means that that x-intercept or that root had a multiplicity of 2, right? So not only do we want to find the x-intercepts, we also want to know its multiplicity. So find the x-intercepts and its multiplicity. The multiplicity tells me what that function does at that point. You have three options. Either your curve is just going to go right through that point nice and smooth, or it may get to that point and bounce, like it not actually cross the x-axis. It's going to bounce. So that's two options. The other option is it goes through there, but it does a wiggle when it does it. All right, so that's your three options. So we'll make a list of our choices and what it looks like. So if a 0 has multiplicity of 1, it just crosses through that x-axis nice and smooth. Okay, and we're going to use the word cross to be shorthand as we do our work, and you'll see us talk about that in just a minute. Then number 2, if a 0 has a multiplicity that's even, any even number, then what's going to happen is, as that function comes down to the x-axis, instead of crossing it, it'll just hit it and bounce back off. Okay? Or if it's coming up from the bottom, it would hit it and bounce back down. Okay? So that's what's going to happen if it's an even exponent up there. And then third, if a 0 has an odd multiplicity, then we say f of x crosses and wiggles. That's not a very complex math term. The official math term for that is it crosses and it's tangent. That's the official math language for that. I'll write it in blue underneath that. It crosses and is tangent. When I think about what that looks like, you know what an x cubed looks like, how it comes down and then it wiggles down like that? That's kind of the look that it has right on the x-axis. All right, so it crosses and wiggles at the x-axis. Okay, so we'll do examples of each of those as we go on, but I'm getting all of our stuff written down. So that was step 1. Step 2. This is step 3. So step 3 is choose points between your x-intercepts to graph. What did you, I think I'm on number 4. Let's see. Yeah, I'm talking about the overall. So I am 3? Okay. All right. Maybe I should make that blue. I'll make it different colors. Okay. If I can ever get it to stay. All right, so just to make sure you've got your things numbered the same way I do. So here, number 1 was our A sub n and our n, and that told us about n behavior. And then our number 2 were these x-intercepts and its multiplicity, and that's the confusing thing because there are 3 things for multiplicity. And now I'm on number 3. Which is our 3rd step. And we're just going to choose points in between our x-axis so we can graph it more accurately. And then number 4, the y-intercept. Remember, you let x be equal to 0. All right, so that will be your notes in one place that you're going to refer back to as we graph. Okay? So now let us get to graphing. So here is our f of x. It's equal to 2x to the 3rd plus 8x plus 2x minus 12. And at first, we're just going to practice finding n behavior, all right, before we work all the way through there. So first, let's work on our n behavior. Let's find the values that we need. Remember, we needed this a sub n. What is the value for a sub n for this one? Remember what a sub n is? It's just your leading coefficient. 2. Yep.
Is that supposed to be an 8x or 8x squared?
It's supposed to be, we'll call it an 8x squared. Thank you. So our a sub n is 2. And then what is our n? 3. That's right. So this is positive, and this is odd. So if all I was asking you was tell me the n behavior, those are the two pieces you would need to look at. And you just think about it, well, since it's odd, one's going to go up and one's going to go down. And since the a was positive, that means as I go to the right, will it be going up or down? Up. So to the right it should go up. And that means to the left it would go down. I'm not saying anything yet about what's happening in the middle. So the part that is odd tells me they go in different directions. And then the a being positive tells me that the right-hand side is going to go up. Right? Okay, so what's my value here for my a? 2. What's my n? 6. So my a was positive, and my 6 is even. So what do I know about my n behavior? What's it going to do? Yes. Because it's even, they're going to either both be up or both be down. And since a is positive, they're going to both be up. So some of your homework just says, tell me the n behavior, and that's what they're asking. Okay. This is 3.4. So we're going to graph 2x to the third plus 5x squared minus x minus 6. So the first thing we're going to want to figure out is tell me end behavior. So we need that value of a, which is what for here? 2. And then the value for n, 3. So that was positive. And this is odd. So my end behavior, I'm just going to write EB for end behavior. My end behavior, are they going the same or something different? Different. And then on the right-hand side, what am I doing? Going up. So I'm going to go up and I'm going to go down. So I know my end behavior. Okay. Now I need to find my x-intercept. So this, remember, this was step 1. Here's step 2. And don't forget, since this is a 3, as I'm trying to find these x-intercepts, what's the most I could have? 3. That's the most I could have. Remember, this has at most 3 zeros. Okay? And then we can say it has at most 2 turning points. Turning points are where it changes from increasing to decreasing. That's what a turning point is, okay? So we need to find x-intercepts. So what's going to happen as we work through 3.4 and 3.5? We're going to go back and have to do all those things we learned in 3.1 through 3.3, finding the x-intercepts. So here, I have no idea. This is not written in factored form. It's not easily factorable. So I'm going to have to use that rational zeros theorem, that thing we did last time with the P over the Q. So that's what we're going to have to do next. So the rational zeros theorem, remember, tell me I've got a P over a Q. And what was the value for my p with this particular function? You remember where it came from? Is it the first number or the last number? The last. So my p is a -6, and my q was the first number. It's a 2, right? And so what we have to do is we have to write down all the factors for p and all the factors for q, and then make a fraction out of that, right? So just to remind us, when I'm doing my p, I'll have ±1, ±2, ±3, ±6. And when I do q, I have ±1, ±2. And I write it in that order so I can see how I'm going to make my fractions. You just choose a pattern that works for you. All right? And we did this in your homework last time. So you're going to put 1 under everybody, and then you'll go back and put 2 in the denominator for everybody and reduce any fraction that can be reduced. When you do that, these are the answers that you will get. ±1, ±1/2, ±2, ±3, ±3/2, ±6. Now remember, this had a degree of 3. At most, only 3 of all those choices will work. And then it's possible that there's not 3 real ones. Remember, I could have 2 complex ones. So it could be possible that only 1 of these works, but at most of them 3 could work. Okay, I have no idea which one of those works, so I just start somewhere, usually with 1. And remember, we talked about you do your synthetic division, and if you get a remainder of 0, yay, it's a root, right? And I told you that that's good if you can find that, because that takes that x cubed down to an x squared. So hopefully we can factor it. So that's what we're going to do. I'm going to try the number 1. I'm going to try 1. So I'm going to divide my polynomial by 1, making sure you don't have any placeholders. And I've got all my x's accounted for. So I have a 2, a 5, a -1, and a -6. Do our synthetic division. And I got a remainder of 0, which means 1 is a root. And if 1 is a root, therefore I can write f of x as x minus 1 times, right? And the reason it's x minus 1 is because this is a positive 1, so your factor looks like x minus 1. This becomes 2x now squared plus 7x plus 6. And since it is a quadratic, you try to factor it. And if you can't factor it, you can try the quadratic formula, and it will spit out the answers for you. This does factor. And it factors into 2x plus 3 times x plus 2. So if 1 had not have worked, I would have needed to have tried maybe -1, then 2, then -2, and you keep trying until you find 1. Remember, I talked about as you're just trying to find the first one, you can plug it in and see if you get 0 for an answer. That's still also going to be telling you that it's a root, okay? So I found that f of x can be written as a product of 3 factors. This first factor tells me that I would have an x-intercept where? At 1. The second factor tells me I'll have an x-intercept where? -3/2. And the third factor, I have a x-intercept where? -2. So here are my x-intercepts. I found 3. Are there any missing? No, because its degree was 3. Yes?
So once you find 1, will they automatically come out whenever you solve for the 0?
So if it says x cubed and I find 1, it should drop down to being an x squared, which should make it factorable. If it doesn't, if I started with an x to the 4th, that just drops it down to an x cubed, and I'd still need to find another one. So basically, you want to find them until you can get down to x squared, so you could just factor or use the quadratic formula. Yes?
So will we get the same answer if we plugged it into the quadratic equation?
Okay, that's a very good question. You would get, if you plugged into the quadratic equation, you would get an actual -3/2 and -2. You would get the answer, boom. It would tell you.
Okay.
The thing that you would want to be careful of is if you did the quadratic equation and you get x is equal to -3/2, but you were asked, what does that factor look like, right? So you would have gone down and you would say, okay, I found out that I have -3/2, and they were saying, but can you write it back? Can you go backwards? Can you write it back like that? Then what you would want to do is you would take that x is equal to -3/2 and like undo it, like multiply by 2 and then add 3 to get it set equal to 0, and that gives you your factor back. Like undo it. Okay? Yes. So that's a good question. All right. So I found my 3 x-intercepts. I wrote f of x as x minus 1 times 2x plus 3 times x plus 2. Remember the other thing with x-intercepts? I needed to know its multiplicity. What is the multiplicity of each one of those? Is it 1, or an even, or an odd? 1. Because if you look to the power, it's a 1. Each of those have a power of a 1 right here. So each has a multiplicity of 1. So what does that mean graphically? Remember we had it was either going to cross, bounce, or cross and wiggle. So what's going to happen at each of those places? Cross. So our x-intercepts, if I want to be real particular, occur at 1, 0, at -3/2, 0, and at -2, 0. And then I'm going to write the word cross, cross, cross. So that's going to tell me what happens there, okay? The other thing that I wanted to find is I wanted to find the y-intercept, and that's really easy to find. Remember, the y-intercept, you just let x be 0. So you're just going to plug in 0 everywhere you see an x. And what do you end up with? A -6. So your y-intercept occurs at 0, -6. That's your y-intercept. Okay. So I'm going to use our x-intercepts, my y-intercept, and my end behavior to sketch my graph. So here's my, it's not going to be so beautiful, but it'll be all right. All right. And that's not to scale, obviously. Okay, so I'm going to first label my x-intercepts. So I've got one at 1, 0, at -2, 0, and at -3/2. So that's like 1.5, so that's inside here. Okay, so there are my x-intercepts. What did my end behavior do? And went up on the right, right? So I'm going to just go ahead and kind of say, I know I'm going to go up on the right, and I'm going down here, right? Okay, so if all I'm doing right now is sketching, and then don't forget my y-intercept is down there. So at every x-intercept, it crosses. So here at -2, if it's going to cross, it's going to have to go up. Let me turn it to blue. It's going to have to go up and back down again, right? And it's got to come all the way down to my y-intercept, come back up, and cross. Okay. So that makes it look like it wiggles there. It doesn't wiggle, remember. It's just because I drew my end before I had my middle done. Really, it just comes on up. So that would be what I would call sketching it. Okay. The step that I didn't go through was where I said, to do a more accurate graph, would be to choose a point in between, you know, each of my x-axis to see how high did it go up, right? Or how low did it go? So that's the only little extra that you could spend time making it as detailed as you want. Okay. So those are the kinds of things that we're going to be doing for a few days. For a few days. Any questions about that? Okay. Now, you'll want to be able to do this without using your calculator. So don't just think, oh, I'm just going to type in my calculator. My calculator's going to tell me. Don't, okay? You're going to have to know how to do this. All right? So let's just talk about this one, because this is nice, because this one is already factored for us. Look, already factored. But what is my a sub n going to be? Remember what a sub n was? It is the leading coefficient. That's what number is going to be in front of all my x's once I multiply them all together. What number is going to be in front of my highest power of x? Oh, I got lots of numbers. Okay, look at your x's. In front of every x, there's a 1. Right? Right now, in front of every x, there's a 1. So even if I multiply all those x's together, I'm still going to get a 1 in front of all those x's. So this is going to be a 1, but I have that negative sitting out in front, so that's going to be a negative 1. Now, what's the degree of my function going to be? I have a 2 on the end, I have a 2, and I have a 1, and I have a 1. That's going to be 4. So the degree of my function is going to be 4. So this is negative, and this is even. So what's my end behavior going to be looking like? They're going to do the same thing, and it's going to go down because it was negative. So my end behavior will be down, down. What are my x-intercepts? I can look right there and tell you, right? Okay, so what's the first x-intercept? At 1. So that would be 0, 1. Or would it be 1, 0? That shouldn't it be 1, 0? Yeah. 1, 0. The second one would be what? 3, 0. And the next one? All right, now we need everybody's multiplicity. What's the multiplicity of this first one? 1, so what will it do? Cross. What's the multiplicity of 3? 1, so it will do what? But what's the multiplicity of negative 2? 2, that's even, so what's it going to do? Bounce and go. So I've got end behavior, x-intercept, and now let's find the y-intercept. You find the y-intercept by letting your x be 0. And that gives you a negative 12. So your y-intercept is at 0, negative 12. So let's use that information to sketch our graph. I'm going to call that negative 12 way down there. All right, so my x-intercepts were at 1, 0, 3, 0, and negative 2, 0. And at negative 2, 0, it bounces and goes. And I know that it's down, down, right? So I know that I'm coming something like that because it's got to bounce and go. And I know at this end, it's crossing, but it's coming down. So I'm coming like that. So I've got that much, all right? And I know that I have a y-intercept down here. So it should have to come down here, cross, cross, and then it's going to come up high. I don't know how high unless I actually plotted a point in between there to get a more accurate picture. But that's the sketch of what that graph would look like. Okay, so your homework is open, and we're going to do more of these next time. All right? Okay, have a good weekend.
I was super impressed.
I was upset.
A little disappointed.
I was too.